checking the settings.
There's a little bit of echoing.
Yep. I can hear. Is it better now?
Yeah, it's gone. Perfect.
Oh. Let me check. Okay, I think we're live now. Hi, everyone, and welcome to our Hazelcast Twitch live stream. We do it like every week. We try to do it every week. We change the time depending on the schedule, and I'm very excited today because first of all, it's on Friday, so it's a weekend, and also the main reason I'm excited because we have the first community user on our live stream. So joining me today, Nico Krieg, a software developer from Germany, who has been a part of our community for quite some time and very active community user as well. So I came to know Nico basically a couple of months ago, where I was introduced to Hazeltest blog post on his website. So I tried to reach out to Nico, and basically we chatted a few bits about the Hazeltest and how we can test Hazelcast cluster. And we agreed to go live and give the opportunity for Nico to tell us a little bit more about Hazeltest. So this is an exciting topic. Feel free to check our blog as well. So there is a guideline on Hazeltest we published this week, how you can use it. But obviously, because we have Nico today here, so he will be telling us about Hazeltest. Hi, Nico. How are you today?
Hi, Voss. Thank you so much for the introduction, and thanks for having me today on this Hazelcast live stream. I'm also very excited, and I'm also a bit nervous, if I'm honest. It's the very first live stream I do, and yeah, I'm very grateful for the opportunity. Yeah, looking forward to presenting a little bit about Hazeltest. The word Hazeltest has been thrown around quite a bit now, so you guys might be wondering what all the fuss is about.
Yeah, that's great to hear. I think before we proceed to talk about Hazeltest, perhaps you give like a little bit introduction about you for viewers. Anything you would like to say about yourself?
Well, okay. Well, what is there to say about myself? I like coding. I like SpongeBob t-shirts. Got out my special one today. What else? Golang is awesome. Coffee is awesome.
That's nice. What do you do? Like, what kind of role you're involved in? What type of work?
I'm a freelance software developer and DevOps engineer, and currently I work for a large German corporation in the financial sector. And this is also where I've been introduced to Hazelcast and learned that, found out that, hey, it's a pretty cool technology to use and it's fun to work with. So, you know, let's dive a little deeper and yeah.
So how is your experience so far with Hazelcast in general?
Well, Hazelcast is an incredibly sophisticated piece of tech, and moreover, it's a distributed system. So a certain level of sophisticatedness also has always has a certain complexity inherent to it. And I think the Hazelcast engineers have done a tremendous job hiding this complexity from the user as much as possible. Because if you spin up Hazelcast, for example, if you simply take the Helm chart as is from the official GitHub sources, you know, you can run a Helm install and there is your Hazelcast cluster and it's ready to be used, right? But then if you want it to be, it can turn into a space shuttle with a bazillion different knobs and whistles to, you know, to tweak and to tweak and configure. And then it actually gets, this is where the fun begins, you know.
Yeah, that's great to hear. So Let's just get going. I think the topic is quite interesting. So I will just tell the viewer that we plan to do basically two parts of this live stream. So this is the first part, and hopefully we will announce when we'll be also live streaming on the second part of Hazeltest. So I will be monitoring chatting now. If you have any question, feel free to post your question in the chat box on the right side, I believe. So I will take the questions and ask Nico. With that being said, I'll give the stage to Nico to go his presentation and what he wants to talk about.
All right, awesome. Thank you so much. Well, in that case, I'm just going to go ahead and share my screen. And let's go to Keynote because I've prepared a little something for you. So, all right, welcome to this very first live stream on Hazeltest, titled Let There Be Load. And as you can probably guess from the name of the application, which is Hazeltest, and from the name of this live stream, which is Let There Be Load, this is about testing Hazelcast, and we'll also talk about generating load. But before we get to that, I would like to give you a short introduction to how Hazeltest came to be. That is the underlying ideas for Hazeltest, because that will make it a lot easier for you later on to understand why Hazeltest works the way it works. And I'd like to kick this off with a little question to you, the audience. Hands up, please. Who's a software engineer? So this is a live stream, of course, so unfortunately I can't actually see your raised hands, but what I'm guessing is that some of you might have raised their hands just now, and if you're a software engineer, the following will be absolutely familiar to you. In fact, you might have recognized testing as a regular and well understood part of what your daily job consists of. And the fact that there's tons of awesome testing tools and libraries available highlights not only the importance of doing testing right, but also provides lots of potential for writing standardized tests. So ideally, any release candidate that you produce has to go through some kind of testing to assert production fitness. And again, ideally, this testing is fully automated. The idea being that you basically press a button and then, go get a coffee while your friendly neighborhood Jenkins or whatever you use as your CI/CD server does its job and generates that release candidate feedback, testing feedback for you in a quick, reliable, and repeatable manner. With that being said, let's extend the scope of our thinking a little bit and look at testing IT systems in general. So if you're given, think about like databases or messaging systems, or indeed a system like Hazelcast. If you deploy that and if you run that, there's usually a bunch of stakeholders who have a bunch of requirements. So the testing process will be different, of course, and because of that, the testing tools will be very different as well. But your overarching goal will likely be the same. You have to make sure that whatever release candidate it is that you test fulfills the set of given requirements. And again, just like in software engineering, the automation of the testing process is hugely beneficial. So you can press a button and again, get that coffee and let the test automation do the job for you. So let's now bridge the gap to testing Hazelcast clusters. And before I get to the testing part, I have to tell you a little bit about how we use Hazelcast at said corporation, because that kind of defines the testing framework that we'll be moving in, and is also partly responsible for the requirements for Hazeltest. So I'm in a small team of 3 people. We provide Hazelcast as a consumable middleware component, which we deploy in Kubernetes clusters. Of course, there's a bunch of business applications flying around as well. They get deployed to the same Kubernetes clusters, different namespaces, but nonetheless, they use Hazelcast to store their state. And at some point, prior to release, the developer teams reach out to us and communicate their requirements. Stuff like, we need a new map with name such and such, number of backups is X, storage format, please make it Y, and considering the WAN replication, we would prefer high throughput over low latency, stuff like that. And then we put all of that configuration into a Helm chart. So all of the cluster configuration plus all of those data restrictions are embodied in the Helm chart. Thus, the Helm chart is our release candidate. And whenever new and changed requirements come in, they result in a new Helm chart and they result in a new release candidate. There are two aspects or two dimensions rather for testing this release candidate. The first one is verifying the syntactic correctness, and that's incredibly simple. You can simply run a Helm lint and get on with it and call it a day. The second dimension, however, is far more challenging and far more interesting. And the second dimension is testing not the release candidate itself, but testing the resulting Hazelcast cluster. And this is the kind of testing that we'll be looking at in the next couple of minutes. So thus far, we've employed two means for testing our Hazelcast clusters. Spoiler alert, both of them are not satisfying at all. So the first one, and the most straightforward one, the most obvious one probably, is to simply ask the developers of said business applications to run the load tests, and then ask them, is everything okay? If the response is yes, then call it a day. But there are a couple of problems with that. The first one being that the load thus generated does not actually correspond to the load patterns in production. So the testing is not realistic. Second, the source code, of course, is not under our control. So fine-tuning the application behavior to really flesh out all of the aspects of our Hazelcast configuration is not possible. Plus, of course, we have no idea how precisely the application uses Hazelcast. So it's a bit of a black box for us. And the third one is that there is actually an organizational gap between us and the developer teams. So we're not allowed to run their load tests, which means whenever we want them to run the load test, we have to call them, and that gets old pretty quickly. So that's not ideal at all. And the second means we've employed thus far is using PowderGrid. If you haven't heard of PowderGrid yet, it's a pretty amazing application. So if you work with data in-memory data grid products such as Hazelcast, but other computing products such as Apache Spark, then do make sure to check it out. It's open source. You can find it on GitHub, and it might serve you very well. It comes with a little testing application too, which is what we've used. It's called the PerfTest app. And the PerfTest app is sufficiently powerful to exhaust cluster memory on one hand and the replication capacities, bound replication capacities on the other. So that such that you can exhaust all of that and make sure the cluster is still stable. But of course, there are other dimensions to load as far as Hazelcast is concerned, i.e. The number of data structures and the number of clients. And you can control both with the PerfTest app, but only in a very, very limited way, which kind of limits the versatility that you have in the load generation scenarios you can come up with. And of course, PowderGrid isn't under our control either. It's open source, yes, but again, there is a huge code base to get into. So it's not really a good option to fine-tune, to be fine-tuned for exactly what we need very quickly and very flexibly. So SIDREP, we're not doing this quite right. In a nutshell, we simply need more flexibility and more versatility in the load generation scenarios that we can generate in order to test all of the aspects of our Hazelcast clusters. Plus, this may only be a little technicality, but I think it's important, so I'd like to mention that. We kicked this live stream off with the software engineers view on testing, right? And then we bridged the gap to Hazelcast. And then I've started to talk a lot about load generation, but load generation does not equal testing, right? However, load generation is the first aspect of testing a Hazelcast cluster, and the other aspects being reporting and evaluation then build on it. So in order to automate the entire testing process, I think you have to get the automation of the load generation right first. And this is where Hazeltest comes to the rescue, hopefully at least. So we have 5 requirements for Hazeltest. The first one being ease of use. When you start working with the PerfTest app of PowderGrid, you'll notice that it's very sophisticated. It even comes with its very own simple properties-based text file-based language that you can employ to configure your tests. But it has no concept of looping, for example. So if you want a test that simply runs for 2 days or something, you can do that, but by copy pasting the same test configurations over and over again. So again, that gets old pretty quickly. So ideally, Hazeltest is a lot easier than that to use. Ideally, Hazeltest should start up and immediately engage all of its intelligent test logic in order to generate load on the Hazelcast cluster. And second, configuration flexibility concerning data size, concerning the number of data structures, and the number of clients. Grid is also not very talkative. So when we use it, we found that it's often difficult to figure out what precisely it's doing. So Hazeltest should come with very elaborate logging mechanisms that produce machine-readable strings, such that, for example, they could be JSON formatted, such that your friendly neighborhood elk stack or a different log analyzing platform like Splunk can easily work with the data. Fourth, we want to optimize it for Kubernetes, because doing so makes sense if you run the application on Kubernetes, but it doesn't break other use cases. So you can still take the binary and run it outside of the container context on a trusty old Linux machine or whatever. And the fifth one, being the most important one, of course, you need intelligent test logic at some place or at some point to generate that realistic load. And yes, we will see later on how that is currently implemented. So I will go over this slide very, very shortly. So basically, in a nutshell, what it says is that Hazeltest is written in Golang, because Golang is probably the best language you can use currently if you're in the cloud native context. Plus, Golang has the best mascot in the history of mascots, and I really needed a good reason to get one of these. That's a little gopher right there. So yeah, Golang all the way, hooray. And the next thing I would like to talk about is the concept of runners. I've mentioned intelligent test logic just now, and the way this is implemented in Hazeltest is that the logic is encapsulated in self-sufficient runners. And the idea is that you can have like a zoo, if you will, of runners that make the load very heterogeneous. I probably messed up the pronunciation of that one, sorry. But for example, there is the Pokédex runner today, which runs on the 151 Pokemon of the first generation Pokédex. Yes, first generation, it is the first generation, I've double checked. And then we have a tweet runner as well, which runs on, no surprise, tweets. There are currently 4 runners available, 2 for maps and 2 for queues each, but the plan is to have a lot more on these in the future. And each runner gets its own Go routine and also its own configuration. And the fact that that Golang has easy to use structures for concurrency and parallelism, or concurrency mostly, really came in very, very handy when implementing this. If you want to take a look at the source code, you will very quickly find out that that those Go routines that the runners get and that the runners run on really sit at the very core of Hazelcast, so they are used a lot. So in order to take the ease of use requirement into consideration, if you start up Hazeltest, it will immediately engage all of the test components if a Hazelcast cluster is available and if all the runners have been enabled. And then more clients is simply a matter of scaling out the application. So this wraps up the theory bit that I wanted to get out of the way in order to make the way Hazeltest works and why it works this way more understandable for you. For us, do we have any questions so far?
So I think there is one question regarding the intelligent testing logic. Could you just describe it a little bit more?
Yes. So when I've worked with Protogrid, I found out that oftentimes you do not need a lot of sophistication or a lot of sophistication when it comes to formulating your tests, but you simply need a bunch of test loops that you can simply engage and run, so that the effort that you have to do stays as small as possible. And Hazeltest uses a concept of a test loop that all of the runners for one kind of data structures use. So, for example, we have the Pokédex runner and the load runner as the available map runners today. And they use, or they instantiate rather, a common test loop that encapsulates the actual interactions with the Hazelcast cluster. So, so far you might actually, the notion of intelligence is currently a bit debatable, but the test loop encapsulates common operations for this data structure and combines it with sleeps, which we will see later on. For example, for map runners, that's putting entries, getting entries, and deleting entries. And it does that over and over again, sleeping, if you so desire, by means of the configuration, in order to generate realistic load. Although I do admit that the load currently is not as realistic as it probably could be. Did this answer the question, or is there a follow-up question? Okay, all right. In that case, let's proceed to the live demo and get our hands dirty. So in this section of the live demo, I'd like to introduce you to some Hazeltest basics, right? Because you will need those for the load scenarios that we will have a look at in this live stream and in the upcoming live stream to be, to make sense. If you don't know the basics, then it will be very messy. So we'll talk about enabling and disabling runners. We'll talk about configuring sleeps. I'll show you how to adjust data structure usage and how to configure the test loops to be short running or to be long running. So let me open up a supportive system here. And then let's actually jump out of this little keynote thing and jump right into what software developers know best, which is the IDE. What you can see here is the values.yaml for Hazeltest. And the config key is the one that houses or contains all of the configuration.
Nico?
Yes.
Just one comment, please, if you can enlarge the font size.
Oh, yes, that's a common thing. Yes, of course. Sorry about that. Right, is this large enough, or do you want to make it larger? Like this, maybe?
No, that's great. Thank you.
All right, you're welcome. Okay, so yes, config element. And what you can see here is that we have Q tests and map tests. So this is for the corresponding data structures, i.e. Qs and maps. And you see the configuration for the 4 runners: tweets load for the Q test and Pokédex and load for the map tests. And each of those comes with an enabled key. And to enable or disable those runners, you simply set this to true and false. So that's pretty straightforward. And I will demonstrate the effects very quickly, such that you can see how this plays out. So the default for this is that all of those runners are enabled by default. And what I'm going to do here is I'm just going to disable all of those runners except the Pokédex runner. And in case you would like to check out the default config, you can find it in here. The path in here is actually incorrect. I need to update this. There has been a refactoring recently. And this is the default config. And you can also find lots of explanations here on what the individual properties do. So This is disabled. This is disabled as well. All right, only Pokédex runner is enabled. What I've done as a little piece of preparation work is I've deployed a little Hazelcast cluster, quote unquote. It's not an actual cluster because we only have one member, but this will get us going nicely for the time being. And let's also take a look at the management center. Yeah, this is what a Virgin cluster looks like. I'm sure you all know that. And right now there are no clients available. So let's just go ahead and do a little Helm install on Hazeltest. So this is something I should maybe mention. If you clone the Hazeltest repository, there are two charts available in the resources folder, one for Hazelcast and one for Hazeltest, of course, to make getting started a little bit easier. So, and what this does is it has actually, whoa, this has actually generated a lot of replicas. Oh, right, I've set this to 50. Okay, well, let's do 50 then, why not? So, and this gives us 50 clients. So no surprise there. If you enabled all of the, if you had enabled all of the other runners as well, this would give us 200 clients in total because each runner receives its own Hazelcast client. So next up, I'd like to talk about the configuration of sleeps because let me just show you what happens. What happened in a very early stage of development when the Pokédex runner was the only runner available and the sleeps weren't a thing yet. So if you deploy this, let's make this only 25 for that upgrade to be a little quicker. So this will start a new generation of pods. So this will take a couple of seconds, but what you can, by the way, this is one side effect of using Golang. The bootstrap of this application is incredibly quick. It's faster than 1 to 2 seconds, and the readiness check does include the check for the availability of the Hazelcast cluster. So that's really quick. And what this does is it now gives us 25 clients, and those clients, I've disabled both of those sleeps. Okay, so let's increase the replica count a bit more to 50 maybe, which is what it was previously. But what you should see is that the CPU load becomes pretty hefty on this Hazelcast cluster. So when we have 800 to 900 clients in our Hazelcast clusters, then the CPU load is, depending on their load, of course, but usually the CPU load is like 10%. And normally it's simply not realistic for an application to hammer on the Hazelcast cluster all of the time, right? And so these sleeps have been introduced to slow down the amount of operations or the pace of operations that those runners do, and they work the same for all runners. So you might be asking yourself what this means between action batches and between runs. The way this test loop works, I'll do this example with maps. The way the maps test loop works is that one action batch is put all and then get all and then delete some, where delete some depends on a random number. And this is 3 action batches, and those 3 action batches constitute 1 run. And so what you can do is that you can configure different kinds of sleeping in order to adjust the load generation behavior to what is realistic in your particular case. And then, of course, you have the num_runs property, which configures the overall number of runs of those action batches. And this works exactly in the same way for queue runners as well, although we have put and poll, of course, instead of put and get and delete. So this is how you configure sleeps. And if I enable these and deploy this again, let's actually dial this up to 50. What you should see is that the CPU consumption is all in all lower than what it was just now. So let's wait for all of those parts to become ready and check our cluster again. I know it's exactly the same. Okay, so I've made a mistake somewhere. I've configured it incorrectly. Okay, so earlier when I did the test run, it worked flawlessly. So in the first time when the sleeps have been disabled, the CPU usage was 90, and yeah, and in the second configuration it was 25. I know it's actually lower, look, but still this isn't quite right. This should be a lot higher when the sleeps are completely disabled. So I probably have made a mistake somewhere in the heat of talking. Sorry about that. But anyway, this is how you can configure the two kinds of sleeps that are available in order to make the load you generate more realistic to your use case. The next thing that I would like to show you, in case there are no further questions at this point, is how you can configure the amount of data structures that you use, or that Hazeltest uses on Hazelcast, rather. We've talked about this as one of the load dimensions beyond the number of entries and the size of those entries. So we have two additional load dimensions, the number of clients and the number of data structures. And this latter point is particularly important because Hazelcast has to do a lot of housekeeping work for every piece of, or for every instance of a data structure. For example, it has to, if you so desire, or if you have configured your Hazelcast cluster in such a way, it has to collect metrics on those data structures. The more data structures you have, the more metrics to be collected. So that quite dramatically influences how that Hazelcast cluster behaves. And therefore, the number of data structures really does matter. Let me uninstall our current Hazeltest installation. Let's just go to 10 here. 10 replicas should get us going nicely, and set those to false. So those are the two properties that control how many data structures this particular runner, the Pokédex runner in this case, will use on Hazelcast. The way it works is actually very simple. Of course, you need a name. The Pokédex runner needs a name for the maps it will use on Hazelcast. And if you set this to true, append map index to map name, what it will do is append, well, the map name, or to be precise, the Go routine name to the map name. So if this was set to true and the number of maps is 10, then this would obviously give you 10 maps. If this is set to false, then the unique ID of this Hazeltest instance will not be appended to the to the map name. So even if you, with this set to true, right, and this set to 10, this will still give us 10 maps in total. And all of those Pokédex runners of the 10 different Hazeltest instances will use those same 10 maps. They will not overwrite each other's entries because the Hazeltest instance ID is actually a part of the key, but they will access the same map. And I will show you that just now. I hope this example works better than the former. So this will start up 10 nice instances, and this will give us 10 clients in total. There's no surprise there. And oh, I should have restarted that, of course, because there is a lot of maps here from our earlier example where both of these properties have been set to true. So we do have a little waiting time for this to start up, and this is probably a good opportunity to talk about the blog post that Fawaz mentioned earlier. So in case you would like to explore a concept in more detail, then this blog post might serve you well. So all of the stuff we talked about in here is contained therein as well, only in a much more elaborate and much more detailed way. So if there's a concept that you find particularly interesting, please do go check it out. And of course, there is also the live demo available. You can see excerpts of the files, of those configuration files, what you can see here in my IDE. And there's also the configuration files of the short little load generation scenario 1 that we're going to do a bit later on. So that was just enough talking to get our Hazelcast instance back online. Perfect. So the Hazeltest is still operational. It just kept running. Of course, there were a bit of a couple of errors because it complains obviously that there's no Hazelcast cluster to connect to, but nonetheless, those instances keep running. And once the Hazelcast cluster is back online, they reconnect and they engage the load, their runners again. So this gives us 12 maps, but to our system internal, of course. So this gives us 10 business maps, quote unquote. And what you see here is the prefix that we've configured for this runner plus index 0 to 9. So let's just set this to true, which will give us 100 instances in total. So 100 instances of those maps, that is. So we'll have, what's going to happen next is that those instances will be replaced. Yep, just done that. And then we will have 112 maps in total. So that's the true system internal plus the 10 from the first little example plus 100 from our second example. And there we go, we have 112 maps. And this, you can see how how the unique ID of those Hazeltest instances is appended to the map name, giving you a much greater number of data structures. All right, so the very last thing I would like to talk about in scope of the Hazeltest basics is short-running versus long-running tests. This was an issue we've had with PowderGrid. It was very simple to define a short-running test, but defining a long-running one was a bit tedious. You just get tired pressing Control V 5,000 times. So one of the ideas was that Hazeltest should be able to should allow you or should enable you to change from a short running to a very long running test in less than 30 seconds. So let's just do that, right? Again, I will uninstall our current batch, set this to 1 as well for simplicity, and do num runs equals 1. And then I'm also gonna disable this particular sleep, or no, I actually need to enable this because between runs doesn't make a lot of sense if you only have 1 run, of course. So let's check our cluster again. Yep, good. By the way, what you can see there, you may have noticed this, is that one of my nodes has become not ready. That is moderately inconvenient, but it's not an issue because the other nodes have enough juice. So never mind that. Yes, okay, this has been deployed, gives us 1 instance, which is what we expect. And this 1 instance by now will be done with its map loop, right? Here we see using map name, blah, 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 in map go routine 0. So this is basically the starting up phase. And then it says map test loop done and finished Pokedex maps loop. But as you can see, the instance keeps running, and that's because the application comes with a little status endpoint. The idea here is that if you build automation on top of Hazeltest, so if you build automation that determines if a test is done, or that maybe gives you a little status bar, how far a test has come, you need a certain degree of insight into the state of the testing application. So I want to show you what I mean. Let's get this IP. I do not have curl available in this container, unfortunately, but thankfully the Hazelcast engineers have provided curl in Hazelcast image itself. That's not metrics, that's status. And this is a little buggy right now. Total once finished should be 1, so there is a bug there. What it should do is contain the status for all of the runners. Right now we only have the Pokédex runner available, so there's the status of only 1 runner in there. But we will see in the next live stream that I would like to extend the detail of this status endpoint a lot further. But yes, that being said, the instance keeps running such that your automation, whatever that might be, can query that. So this was a very short running test indeed. It only took, what, 10 seconds or so. So if you probably guessed how this works, right? If you want the test to be very, very, very long running indeed, you can simply provide a large number of runs. And the variable reading this is a UN32, and that gives you a lot of breathing space. And I don't actually know the max value by heart, so I had to Google this earlier. Thank you, Stack Overflow. So let's just provide that. That's 4,294,967,295 runs. It took me about 10 seconds to pronounce that number, so it's probably large enough. It's not an endless loop as such, but it's long enough to, it might outlive you. So let's actually do that. Let's just deploy that. And yeah, this will inform us about the status here in the logs. So every, I think, 50 finished runs, it prints a little statement saying I finished 50 out of X. And this will, with this number in place, this will run for quite a while. So don't worry, we will not wait until this has finished. All right. With those basics out of the way, let's actually get to the fun part. Which is this load generation scenario 1. There are 2 more, which we will take a look at in the live stream too. But for the time being, we will focus on scenario 1, and we will use Hazeltest in order to identify a very simple misconfiguration in a Hazelcast cluster. Yeah, so the way those scenarios work is that I've provided a little, I've provided sample values.yaml files, which you can use in this little repository of mine. Here it's called blog examples, so it probably contains examples on my blog. And the way it works is that there is the first Hazelcast values.yaml is the faulty one, and the first Hazeltest values.yaml is the one that the Hazelcast cluster will be able to deal with. And then we move on to the next one, which is the one that will break the Hazelcast cluster. And then the 4th one contains the fix. So those are available for you over there. And you can just query or copy paste them from there if you want to follow along. I will just copy them over from the IDE, which I've opened over there, because that's a bit quicker, right? So let me make sure the zoom bar is in the way, right? All right, there we go. All right, so this is the Hazelcast configuration, and I can already apply this because it will take some time to start up. And while this starts up, let me provide the Hazeltest as well. And this is very small. I will increase that a little. So let me walk you through it. The configuration is very, very simple. And what you'll want to put your attention on is the map config, because this load scenario will work with map runners exclusively. And so we have only 3 configurations here available. We have a default configuration with a max idle seconds timer of 30, and then we have app1 asterisk and app2 asterisk. And as you can see, those have eviction policies defined in contrast to the default configuration. And so those also have higher max idle times. And we will deploy Hazeltest now. So this will give us 2 instances. And the 2 queue runners have been disabled for this because, as mentioned, we'll focus on the map runners instead. So the Pokédex runner is there, and the load runner will make its appearance as well. The load runner is a bit special because the way the Pokédex runner works is that it simply uses a little file here. It's actually embedded right with the source code. So you have this little Pokédex.json, which contains the 151 first Pokemon, right? So the data size, or the size of one entity of this, is pretty much limited. You can't do anything about it. In contrast to that, the load runner, in order to honor its name, can generate more load on the memory in particular by enabling you to specify the payload size in bytes that you would like to deploy or unleash onto the Hazelcast cluster. So yes, Hazelcast is there. So let's just deploy that as Hazeltest app1. This will give us 2 nice little instances, and you may have spotted something interesting here. We have this prefix is app_1, so this will actually catch the default configuration of our Hazelcast cluster, and our Hazelcast cluster is doing fine with this, right? So the map consumption obviously increases, but the eviction policy defined on app1, excuse me, will make sure that the actor actually writing a lot of data, which is the load runner in this case, will not crash the Hazelcast cluster. So this will stop somewhere at 80%, and it will roughly stay there. And despite this, we have the app1 Pokédex map being filled with entries, and this number is a lot higher than 151, of course, and that's because all of the map go routines, which are currently running in this runner, access that same map. And as you can see, the load runner actually generates a lot more load on the memory than the Pokédex runner. So this is fine, right? Let's switch to the Hazeltest configuration that will actually blow things up. And it's important that you deploy this as Hazeltest app2, it says here in a little comment. And the difference here is that this time the load runner, so this is prefix app2 in order to distinguish those maps from the first set of maps that we've deployed. And this time the load runner will use app2 as well. Notice the underscore, so this will catch the default configuration as well. So the question here is the default configuration defensive enough to protect the cluster from a misbehaving client? Where misbehaving simply means that the client does not take into consideration a naming pattern that may have been previously agreed on. So app2, there we go. This gives us 2 more instances. And let's head to the Hazelcast dashboard very, very quickly. And what we're going to see next is how this free space percentage will decrease quite substantially. And at some point, of course, we will see the infamous out of memory error, and our nice little cluster will crash. So this is only a matter of time, of course, and should be there in a minute. By the way, if this weren't, so the crash is happening now, but if this weren't fast enough and you wanted to make things worse, a lot worse with the Hazelcast cluster, you could just go ahead and increase the number of replicas that you use here, which would completely fry the Hazelcast cluster. So at this point, it starts crashing, and we already have the second part, and somewhere in there must be our infamous out of memory error. Okay, I'm not actually going to search for this right now, because I know there's an out of memory error floating around there somewhere. So this is not a stable cluster. You probably agree with me on this one. So let's see what we can do about that. Let's pull in the final Hazelcast configuration. And there are two dimensions we can adjust. The first one is the max idle seconds, of course. This is set to 5. So that is significantly lower than the 30 seconds we had just now. But when even that would not be sufficient or sufficiently defensive to protect the cluster if you have a misbehaving client that generates so much load so quickly that the cluster will not be able to accommodate that additional data even for 5 seconds. Plus, what happens if the max idle timer is actually never reached because the client keeps reading that data, right? In that case, it won't expire those entries. And thus, we need an eviction policy. And in this case, I've gone for a free heap percentage with a size property of 85, which is, of course, very, very defensive. This means that if you have, if 15% of the available heap is used, then this eviction policy will kick in. And in the upcoming live stream, in the second one, you will see why free heap percentage may be the more appropriate choice here rather than used heap percentage. But let's cross that bridge as soon as we come to it, and just deploy Hazelcast again with this configuration. So, yep, deployment is done. Let me just speed things up a little and get rid of that. So this will take a couple of seconds to become ready. So what is the expected output of this? Hazeltest app 1 is not a danger. It wasn't even a danger for the first Hazelcast configuration that we've looked at. Hazeltest app 2, on the other hand, is. So what we expect now is that despite the fact that we have a badly misbehaving client here, the cluster should remain stable. So, and with a bit of luck, yeah, let's click those away. Go check out the maps. So you can see the effect of those of this prefix property in there. Let me show you this as well. So you can define a map prefix here, and yeah, it basically gives you the opportunity or the option to configure your maps in such a way that they align with the Hazelcast map configuration. And things do look a lot better than they looked before. So the memory consumption, the overall heap memory distribution should stay roughly like so. So we have usage of 80.3%, roughly 80%, and it should stay like that. And let's check the logs as well for the sake of completeness. And the logs are fine too. And let's just run this. Let's just keep this running for a little while and head back to our presentation. But first things first, before we get back to the presentation, actually, are there any questions so far on the on what we've taken a look at right now?
That's great, Nico. Thanks so much for what we discussed so far. So there was a question about the short running versus long running tests. Someone asked about the criteria for defining short running versus long running tests. How do you determine this?
Well, that's entirely up to your creativity. So the sky is really the limit here. So I can only give you an example, really. For me, a short running test would be a short functional test. For example, when you've deployed to production and you know that the first client applications will go live in 30 minutes, which would be bad planning in a way, but you don't have a lot of time to do an extensive load test to make sure that everything works right. So all you can do is do a simple smoke test or a very short functional test. So in this case, you would configure, the runners that you need in the way that you need them to run for, let's say, 5 minutes. So you would maybe go for something like 100 runs or maybe 50 runs and configure this to be, I don't know, 1,000 milliseconds between runs. 2,000. I have no idea if this actually would run for only 5 minutes. That's a matter of playing with Hazeltest and getting a feeling for how the runner configuration and how the sleep configuration plays out. But this should give you a reasonably short running test. And then a long running test, for example, what we do when load testing Hazelcast is let a test run for at least 2 days. So 2 days under full capacity, full load, and then after 2 days, check all of the logs via the logging platform, not even in the pods themselves, to make sure that there is no out of memory errors or no other errors in the logs. So in a nutshell, this depends on your specific use case.
That's great, Nico.
Okay, are there any other questions?
There are a couple of questions, but it's more general questions like regarding Hazeltest. So I don't know if you want to take these questions now or towards the end.
If they are generic questions, not related to anything that we've done in scope of the live demo, it's just taking them at the end. So I think the end is supposed to be a kind of open discussion anyway. So
yeah, let's do
if there
this.
are generic questions. All right, perfect. So let me do a very short preview for livestream 2 then, so you know what you can expect from livestream 2. So as mentioned previously, there will be 2 more load scenarios, and these are still work in progress. So I can't tell you just yet how precisely they will look like, but it's very, very likely they will focus on the other load dimensions. So we've covered the number of entries to be stored plus their size thus far, but as mentioned, there are 2 more dimensions as far as Hazelcast is concerned, namely the number of data structures and the number of clients. So we'll talk about that a lot. Plus the road ahead. So there are a couple of improvements that I would like to implement for the existing runners. Also, mentioned earlier, very, very shortly, load generation doesn't quite equal testing. There are other aspects of it as well. And I'd like to shed some light on the take on, load generation versus reporting versus evaluation, and how far Hazeltest will go towards automating these things. And last but not least, there will be a little feature introduction for an idea basically for a feature you could call a chaos monkey. Depending on how much time passes, I might even be able to show you this live, because maybe the feature is already done. So let's do a quick summary. In a nutshell, we've learned that automated testing is important even outside the scope of software engineering. Hazelcast configuration is embedded in a Helm chart in our case. And the tests we run, i.e. the load tests we run, not the test for syntactic correctness of the Helm chart, are run against the resulting Hazelcast cluster. The testing means we have employed thus far have not delivered satisfying results because they lacked load generation versatility that we needed to really test all aspects of our Hazelcast configuration. And Hazeltest attempts to do a better job at that by providing automation for flexible load generation, by implementing or by offering runners that you can flexibly adapt to the particular use cases you have, to whatever might be realistic load in your scenario. We've worked with Hazeltest basics, and we just went through a simple load scenario in order to show how you can configure runners to find a misconfiguration in a Hazelcast cluster. And in live stream 2, there will be a little bit more load generation plus a take on the road ahead. And this wraps up all of the content that I have in store for you today. So Fawaz, if you want, we can come to the questions.
Yeah, that's great. I think we can stop sharing screen and go back to discussion here. Thank you very much, Nico, for this live stream. I think it's quite interesting to hear about testing scenarios and hearing from you about Hazeltests. Do you want to break, or shall we carry on? Because you've been talking for quite some time now.
No, I can go on if it's fine for you. I think you're the one to be thanked because this was planned to be only a 30-minute session, and I may or may not have gotten carried away. Sorry.
No, it's all right. I think this is quite nice. I've been tracking the viewers and looking at the questions here. So I think it's quite interesting to see people joining. And I think it's also a very important part, basically, because after all, you want to make sure that whenever you have the opportunity to do the test, I think one of the missing parts is like doing it right. So first question for you is, what was the most challenging part in developing the Hazeltest in terms of, writing the code and doing the tests?
That's a very nice question. So what's the first steps for developing Hazeltest were under quite a lot of time pressure because we had an issue prior to a release, and we were unable to reproduce it using the business applications in PowerGrid. So the hardest part was implementing this feature without incurring too much rough edges around the code. And this hasn't quite succeeded, so there was a refactoring afterwards. And also Golang is completely new for me, right? And so implementing this was awesome, but as I learned more stuff about Golang, I looked at the source code at some point and thought, oh boy, that's ugly. And so it was quite challenging to look at this afterwards and think, oh boy, I'm the one who has committed this.
Yeah, that's great. I think also like a question related to these questions from Sebastian. So I'm just gonna read the question. So what are the top issues found by Hazeltest in your customer implementation? Question mark, mostly config problems, for example, or is it more used to prove your fulfill customers' performance requirements?
The latter. I would say in general the latter, because our developers are very nicely behaving clients. So we didn't have a single misbehaving client, I think, which is good. I hope it goes on that way. So I've mostly used Hazeltest for load generation, actually, in order to make sure that the cluster remains stable, even when it is under a lot of load. So we do have VAN replication enabled, and VAN elements are stored on the heap. So even if you store stuff in the map, even if you store map stuff in the HD memory, you can still incur too heavy a load on the heap if the VAN queue runs full, right? And we've also had a couple of issues with scaling out and scaling in Hazelcast. And so it was rather challenging to come up with a Hazelcast memory configuration that strikes a good balance between the number of members on one hand and the capacity they use in our Kubernetes clusters on the other. And in order to get this memory configuration right, the load runner for the maps in particular turned out to be, I would say, decently useful.
Okay, great. I just remind the viewers, if you have any question, to leave it in the chat box. I'll get it to Nico. So I think I've read the article. Basically, also once like we got the exchange between, you know, what we need to do and so on. And I watched the presentation. So one question came to mind is, do you have like best practices in terms of doing the tests, like in terms of what do you recommend so that you can share?
Yeah, absolutely. So I would recommend not to pay too much attention to what each property does, and instead simply focus on getting your hands dirty with Hazeltest, because this will give you a head start in learning how the application behaves and how the load generation works on Hazelcast. So in case you do need to dive in, there is the default configuration file, which provides all sorts of explanations that you need. I hope they are descriptive enough. I hope they are clear enough. In case not, please do let me know. And then obviously I'll give my best to improve on that. Yeah, basically get your own, I don't know, if you do not have a Kubernetes cluster ready, get K3s, get an old Linux machine or something. Get your hands dirty with Hazelcast and Hazeltest.
That's great to hear. I think we don't have any more questions here. So I would like to thank you for your patience, basically, and your time. It's been really nice working with you. I think, you know, having you here on our live stream as well as the Hazelcast blog is beneficial for our community. First, to learn about Hazeltest, but also, you know, to make it, you know, encouraging for others also to join and share their experience using Hazelcast. We will make sure to have this live stream available on YouTube afterwards. So if people want to watch, any final words you want to say or anything you want to talk about for the live stream too?
Well, my final words would only be thank you for being here. That's to you, all the people watching this. Thanks for being here. Thanks for sharing your precious time with Fawaz and me. It's been a pleasure and an honor being on this Hazelcast live stream today. And so thank you to you, Fawaz, as well, for all of the background work that you've done behind the scenes in order to make this work. Thank you very much.
Yeah, thanks very much, Nico. To be honest, like when it was announced it will be Friday, I was like a little bit, stressed, because it's like usually people leave early on Friday and we don't usually know exactly what's going to happen for next stream. But this stream was really active in terms of viewers. I've been watching stats here. So this is really a very hot topic and nice topic to hear. And so I would like to thank you for, spending time with us on Friday afternoon. And yeah, we will look forward for live stream 2, which we will announce when it's ready. All right. Thanks everyone for listening and viewing, asking questions. I hope you enjoyed this live stream. Feel free to check our Slack community channel, where you will have access to our engineers and know about best practices. And we do announce topics about next live stream. So thanks everyone and have a good weekend. Bye-bye.
Have a good weekend. Goodbye.